Hello everyone, dear friends. We sent a fairly rare device for repair on this channel. There have not been any such devices yet. This is a wireless Wi-Fi, an Inkbird thermometer specialized for culinary purposes. This is a problem for the grill specifically. After getting caught in the rain, it stopped working. The owner tried to dry it, but this did not give the result. At the moment, the device does not respond to the power button. In this repair, we will try to figure out what could have happened to this thermometer. Let's start by disassembling the screws on the case. I couldn't find them anywhere, even under the rubber feet. Well, they still have to be, because the body is so easy to disassemble. Clearly it is not assembled with latches. All that remains is to peel off the glass by heating it with a hairdryer. The temperature is 150 degrees and it easily succumbs to the suction cup. I didn't even have to pick at anything. The glue layer of the glass is preserved, and I will install the glass on it when welding. Now, I'm unscrewing the winds and disassembling the case. Here we can observe the display and part of the electronics board. On the components to the left of the microscope, there are clear traces of liquid ingress, greenish deposits of oxides in appearance. There is no major damage here. Most likely, it will be enough to simply wash off the oxides and clean them thoroughly. It's possible that a small amount of soldering on the components might be necessary, but nothing beyond that. I want to inspect the other side of the board, but I'm unable to remove it from the case. It is undesirable to make great efforts so as not to bring the dress additional damage already mechanical. Well, then let's work on this side of the board, flushing the oxides with gasoline galoshes. In fact, this turned out to be enough. The condition of the components is perfect. You can even try to turn on the device. When connected to the charger, the thermometer is turned on the screen, and the F value is 0 on all channels of the temperature sensor. The button does not exit to turn off the device. There is no response to pressing. What we'll definitely have to study the backside of the board, removing it from the case and disconnecting the battery. There are traces of flooding here too. This got the microcontroller. The liquid clearly came from one of the connectors for the thermal sensors. Things are getting more complicated here. Maybe something has even corroded badly. I also washed the oxides using gasoline. And now let's look at the results under the microscope. Here it is. The controller from the company Armpike looks good from all sides. Only these two conclusions raise doubts. Wouldn't it be superfluous to solder with flux from all four sides here? Sections 2 tracks, I restore them with a scalpel, peel off the mask of entire sections of tracks, wash off the used plus, apply a new one, and grease. Next, I solder copper wire to the place of the brakes. In general, this is a typical job when restoring tracks. It is noteworthy that every year the tracks become thinner, but so far there is no difficulty due to this. Designed to secure the wire well, no additional fixation is necessary. However, you can always apply a bit of glue, such as 7000. Well, let's see how the device behaves now. I connect the battery, the thermometer turned on the screen, some incomprehensible symbols. Obviously, the battery is discharged. The voltage on it is less than 3 volts connected to charging. The charging current is good, about 800 milliamps. After some time, the battery is well charged. The device gives a value of E1 on all channels of temperature sensors. Again, there is no response to pressing the power button. On metrics, turn on voltage. For some reason, not at all. Accordingly, the device does not see the microphone. It does not see the pressure, although the working microphone itself closes the terminals when triggered. It has identified such a moment that when a kilovolt voltage is applied to the signal contact of the microphone, a pressure is detected. The device turns off the problem from the part of the circuit through which voltage should be supplied to the microphone. What are we looking for? Where did the tension from micric go? The signal tracks go under it, so you will have to solder it carefully, unsoldering it with a soldering iron. The voltage at the terminals of the microscope is pulled up along this path. And here, there's a transition hole that connects to this track on the back of the board, checking the condition of the track under a microscope thoroughly. Everything is rotted here. Possibly liquid got inside. Now you need to restore it using a sewing needle. I pierce the transition hole so the wire can pass through. Then proceed with the same soldering work as with the controller. Done. Soldering the micric in place, and you can test the functionality. Great. Now the button works. Checking the connectors for thermometers. All work except one on it. Even without a sensor, the temperature is about 70 degrees. Something happened to the first channel. I checked connector 1, everything is fine with it. Everything is also fine with the tracks. The signal from the connector immediately arrives at this microcircuit. That is, it is obvious that the problem with the controller, in order to eliminate the defect, you need to change the microcircuit. It comes with the firmware, so I won't change it now. I have no idea how she sews. As I understand it, you need a programmer for chips with T32, but I don't know for sure. I've never contacted this. If you have information on the firmware of such chips, then write in the comments and I will try to fill this gap in my knowledge. One way or another, the owner does not use more than 2 thermometers at the same time, so there is now even a margin so that random values are not displayed on channel 1. You can shorten one connector. For this purpose, install the threaded part of the screw in the connector hole. This also protects against incorrect installation of the thermal sensor. After that, the data on channel 1 stopped being displayed on the device itself of their suggestions on the smartphone. Upon further testing, no additional problems were found, and the repair was completed. The device is sent back to the owner. If you don't fill it anymore, then I think that the resource of the device will be unlimited. Well, dear friends, that's all for today. Thank you all for your attention, and see you soon in other repairs.